Hello, everybody. It is Mrs. Cinti, and I am here to talk to you a little bit about the forces, the nature of forces, as well as friction and gravity. So get ready. This is a full one today. So first things first, let's talk about what force is. Okay, force is the push and pull. So by definition, it is the push and pull. Okay, push and pull. There you go. You got it. Push and pull. So anytime that an object is either pushed or pulled, that there's a force being exerted on it. Okay, it is described. So the way that we describe it in the scientific community is by by recognizing both the strength of the force and the direction of the force. Okay, so those are the things that we pay attention to. So for instance, like in a tug of war game, we could have somebody here, and if they have a rope between them, that they're pulling on, okay, the length, the way that we label it is the length of the arrow shows which one is stronger. Okay, so if it's a really long arrow like that, that means that this is that's a stronger person, versus an arrow like this, which is shorter, that length of that arrow is shorter, meaning that this is the weaker force here. So between these two people, this person will probably end up winning. And so that's force. So how do we describe it? We are going to look at it in terms of Mr. Sir Isaac Newton was the one that helped us kind of discover this kind of idea. He was able to put it into words. And so we honor him by having the SI unit of force be in newtons. So we use a lowercase to say what a newton is, but then the actual letter is a capital N. A lowercase n represents moles, which is something else. So that's why we want to pay attention to definitely using that capital N. Okay, and it's in honor of Sir Isaac Newton, who did a ton for us in the physics world. You can see all this, like this here, the apple falling on him, which we'll talk about later, the moon. He talked about this prisms and light, electromagnetic radiation, a telescope, blah, blah, blah. You know, the list goes on with this man. He's an Englishman, and he did a lot of good work. So how do we calculate force? So we got to get into calculations a little bit. In general, if there is an unbalanced force occurring, so if there is a weakling, like we just saw my stick figures, and then a stronger, well, not weakling, you know, two very strong, healthy dogs, but one of them just happens to be bigger and stronger. What we would do is we would calculate the force, okay? So when two forces are acting against each other, okay? So when they are acting against each other, what we do is, wow, it is hot in this room, against each other. What we do is we subtract the smaller force from the larger force. And so logically, right, the bigger dog is going to win here, the one exerting more force units than the weaker one. And the difference between the two is the actual force that is going to be exerted. So the net force. So the net force between these two is going to be equal to 12 minus 10 newtons to give us 2 newtons. And who's going to win? The big dog. So this rope is going to be pulled in this direction. And if we pay attention to our arrows, here's the longer arrow, and this little dog is pulling in this direction with a shorter arrow. Very strong, but not quite as strong as this one. So that's how you calculate an unbalanced force. Okay. if we have two forces working in equal, and pushing in equal direction. So here's a diagram from your book. So here are two dogs again. Sorry about the dogs. I love dogs. They're great. So here are two dogs. They are both pushing in the same way. So see, this one is pushing more, so the bigger arrow, a little bit less. Oops, but the total force being exerted here is 16 plus 10, a total of 26. So the net force, the total force that we are seeing is 26 newtons. Whether or not this moves or not is still another calculation and discussion, but it at least is being pushed by 26 newtons. And then here again, here are two dogs pushing in either direction, opposite directions. This one is pushing with a force of 20 newtons, this one of 10 newtons in the opposite direction, and so the net force difference is 10 newtons, okay? So that's it. So what happens if two things are pulling on the same item and they are both equally strong? Here is an example with some elephants now. Here, this elephant is strong enough to be able to pull with a force of 200 newtons. This one is also 200 newtons. So what we do here is if there is a net force change of 0, then what we would say is that there will be no acceleration, no movement whatsoever. There is no movement. What I should say actually is acceleration. Here, okay. So that's an image from Encyclopedia Britannica, just to give them credit for these great images. I'm using Google Images on all of mine, so thank you everybody who has contributed to this PowerPoint. Okay, and now let's move on and talk about friction here. Okay, so this is the next lesson here, friction and gravity. So what is friction? And here is your definition right here. Friction is a force that two surfaces exert or put on each other, or spend on each other, I guess, when they rub against each other. Okay, so the friction is right here. So when you're pushing this book or this box across a table, it's not flying across the table unless there's very little friction here. So if it has a really soft surface, if the box has a really soft surface and the table has a soft surface, it may move a lot more quickly and a lot more easily. But if you put rubber, I don't know if you've seen some of the mixing bowls these days or serving bowls have rubber on them. That's so you can't, so they don't slide off the table and they don't slip. But people push them thinking that they're going to slide off the table. And so when I was getting used to it, I pushed over a couple of our serving things just because I thought that they would move, but the friction was so strong that it could not move. Okay, friction acts. One other important detail is that friction will act or acts in the opposite direction of the object's motion. Okay, so you saw here, and I covered it up because I was doodling a little bit, but you saw here that the pushing force, this box is trying to move this way. The motion is in that direction, but the friction is acting in the opposite direction. Okay, so that's what that is showing you there. Okay. Another example is if you were to spin your pencil on a table, right? You could spin it on a table. If you tried to spin it on the table without a tablecloth, let's say that you don't have a tablecloth. If you were to spin it, it would spin pretty quickly, right? So I can't really see the video that I'm making right now, but you could spin it like this and it would move really quickly. I'm being gentle because this is a nice pen. But then if you were to put it on a different surface, a rubber surface, or if you were to put a tablecloth on, that would create quite an issue because suddenly it wouldn't spin as well. And for obvious reasons, there's more friction that occurs with different surfaces. Okay, there are four categories of friction, and we're going to go through each one of these, but this is kind of exciting. So there is a sliding friction, okay? And what the sliding friction does is it makes moving objects slow down and stop. Okay, so slow down and eventually stop. So if you think about if you've ever been like a nice hill and you go to roll down it, you eventually slow down, and that the reason for that is because of this sliding friction. Here's somebody going extremely fast down a hill, and so he's freaking out or she's freaking out because there's very little friction between her skis. She has skis, which, you know, they do a lot of things we'll talk about eventually, and then the snow, which is slick and icy. It's another surface. And then here's the grass. He's trying to slide down, but he's probably not going to move at all, except if it's wet grass. Then maybe he might slide down, and we'll actually look at that in a second too. Why wet grass slides more quickly than dry grass. And so the next type is called static friction. Static friction is the force that keeps you or keeps the object, it was supposed to be you, not your, the object from moving at all. Okay, and that is why a couch is really hard to move, okay, because there is a force, the static friction, keeping it from sliding, keeping it from moving. This can be overcome. As you know, we can move a couch. This can be overcome with a force, okay? So you can slide a couch, but sometimes you really have to put your back into it. Sometimes like it's much easier to slide something based on the surface that it's on, and that would be that sliding friction right there. But there is a static friction as well. Okay, the next friction is, I think, one of the cooler ones. This one is fluid friction. Okay, fluid friction occurs in two types of fluids. There is water over here. So there is the water fluid. So it occurs, in or within water and air. Okay, so we have the water over here, and then we also have the air over here. Okay, water and air. And it occurs when solid objects, and so this plane or this bird or this person, when solid objects move through one of these liquids, or a fluid, sorry, not liquids. It is extremely easy to overcome. So adding that fluid there makes it much easier for this guy to slide right down here, or this plane to fly through the air. And this is the reason why sidewalks get really slippery when they're very wet. Okay, so another cool concept right there. And then we have the last one called rolling friction. Okay, rolling friction is the last type of friction that we'll be talking about because it's the fourth one. And this one, oopsies, let's go back here. Sorry, I'm skipping ahead here. Boom, boom. And rolling friction occurs when an object rolls across a surface. Oh, I'm clicking buttons here, left and right here. Oh man, what did I just do? Here we go. Here we go. And we're back. Oops, but we have to go here first. I have some buttons on my pen here, and so sometimes those buttons get a little crazy. Okay, rolls across a surface. Well, that's good to know that if I click a button, maybe it will help me. And so you can easily overcome this friction. It's easy to overcome if the object can roll. And so the way you want to think about that is this bag right here, right? If he were just dragging it, it would take a lot more effort for him to drag this bag. But now that wheels are put on suitcases, it all of a sudden just rolls right along, and it takes very little effort and energy for people to use that. Okay, so let's move on to the next lesson or next chapter here. So gravity. I don't know if you saw previews to this. Frankly, I never could even watch this movie. It looks so frightening, and so I couldn't watch it. But the main gist of it is that there's an explosion when they're outside on their spacecraft. They're out in outer space, and somebody is somebody, like, the explosion pushes them back, and so they float away from the spaceship, and because there's so little gravity, there's so little everything, it was difficult for them to get back to the spaceship. And I never saw the ending, so who knows. If you were, Gravity's awesome as well. They have little simulators, and they even have planes that you can go up into, and they simulate, or rooms that simulate gravity, or zero gravity, that kind of concept. And people can hit golf balls, and the golf balls go flying so much further. Like, all of a sudden you feel like a superhero, because when you swing that club, or when you hit that tennis ball, or when a baseball player hits a ball, the ball just keeps going. It keeps going. All of that friction, all of that is kind of out the door. There's not a lot of gravity. There's nothing really keeping it from moving, which is really, really neat. Could you imagine if you ever decided to go skydiving, all of a sudden you jump out the window of the plane and you don't actually fall, right? All of these are examples of why gravity, we take it for granted, and why we just assume. And this is Newton. He's the one that really thought of the beginning concept of gravity. He did a lot of research here, and the reason why is because one day he was sitting underneath an apple tree, and an apple fell on him, and he wondered, why did it fall on me? Why didn't it fall a different way? Why did it have to fall at all? Like, why do, when I throw something in the air, I throw it way up in the air, how come it falls back down and to the ground eventually? So he was an integral part in discovering the concept of gravity. So what is gravity? Let's go ahead and move this. Gravity is, let's put some notes here and say, gravity is the force that pulls objects together. Okay, it keeps things on Earth, objects on Earth, and that's the reason why a baseball doesn't keep flying, even though it's in a trajectory up, 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 it eventually comes back down. It keeps the moon revolving around the Earth. It keeps the planets around the sun. Pretty impressive stuff, right? Pretty impressive stuff. Gravity, and one kind of factor, one final thing, is that everything with a mass, everything with a mass is attracted to each other. To each other. So in fact, as you're sitting here taking notes on this, your computer is attracted to you. The items on the desk are all attracted to you. Okay, and so what makes the computer not fly right at you and attach to your face, right? What makes everything not go flying around? And so there are two things that gravity is affected by. One of which, here it is. Gravity is affected by both mass, okay, by the object's mass as well as the distance the objects are away from each other. So in general, the more mass an object has, the greater the gravitational force between it and other objects. So, classic example, the gravity, why things fall to the earth, what is heavier than you, right? If you're standing in a room and you're just in a room and here's a pencil and you go to drop it, how come it doesn't land on you? Because you have mass, right? You are made up, you're an object. And the key is that the earth has a whole lot more mass than you do. But I'm using the word mass, and you may be thinking, gee, what does that word mass mean? And so let's talk a little bit about the difference between mass and weight, okay? Because there is a difference between those two. Mass versus weight. What mass is, to just define mass for you, let me get a different color. Let's do this. And what mass is it is the amount of matter in an object. So basically, I know that you have an understanding that everything is made up of atoms, okay? So if you were to go and count how many atoms are in your entire body, it would take a really long time, but if you were to do that, right, that is your mass, because that's the total amount of matter, of material that makes up you, okay, that makes up a table, that makes up anything. So it's the amount of stuff that is inside that object. And so you would be the object, or the table would be the object. Weight is actually, weight is kind of cool. It is the measure of the pull of gravity on an object. Okay, so that's kind of cool. It's the measure of the gravitational pull right there. And so what that means is, because gravity is different on different planets, as it turns out, so Earth has the same kind of, the same gravity. There's no change in the gravity on Earth. Okay, so on Earth, the force is about 60 newtons, is what this sign is saying. And so your mass, let's say that I weigh, or no, let's say that I'm not going to go there. But let's say that I take a box, and the box weighs 100 pounds, okay? The reason why it weighs 100 pounds, the weight is 100 pounds, the reason why it weighs 100 pounds is because that is what the Earth is pulling it down and pushing it down on that scale to read 100 pounds. The Moon, on the other hand, has a much lower gravity, and so the force being exerted, the gravitational force being exerted on the moon is much less. And so your weight, and I'm totally making this up, I have no, we aren't going into calculations, would be much less, right? Let's say that you're suddenly, I don't know, 45 pounds. I'm trying to remember what it would be. So 45 pounds here, okay? Big difference. But you're the same person, right? So if you were here, you weighed 100 pounds. If you went on to the moon, you would be much less. And then check out the gravity, 20 newtons on Mars, okay? You would be a bit heavier. There's another one that I saw, Saturn. Saturn's a huge planet where the mass is like outrageous. Or if you stood on the sun, you'd be like 1,000 pounds, something like that. So kind of cool to research. You could just Google image this concept, and you would see a lot of different examples of what the masses are. And then distance, just one short thing about distance. As far as we had said that gravity is affected by mass and distance, the further away two objects are from each other, the less the gravitational pull on them. Okay, so the less of the pull on them. So in this example, assume that the two objects are equal distance apart. Between which pair of objects would the gravitational force be greatest? Between which two would it be the least? So take a moment and think about that. Put that in your notes. And let's get actually just one more thing. Oops. Oh, man. I was going to just repeat again that distance, the further away, the less the pull of gravity. But clearly I can't find that thing again. So have a great afternoon.